Okay, so this is to help you guys out with the lab. This is 12 molar. We got our times in seconds. We got the mass of the system. Obviously, this is in grams. And the first column we want to do is the reason the mass is changing is because the carbon dioxide gas is being lost to the environment. So, how much is being lost to the environment? Basically, in the beginning, we have none lost because this is kind of time zero. But then what it is we want this cell value to equal the difference between this cell, and so we're going to go that cell minus this cell and hit enter. So that's the difference between these two, and then we want to continue that all the way down with the difference. So it's changing by 0.36, 0.36, then we've got it by 0.05, then 3, that's a little bump, then back to 5 again, 4 to 6, little bump, and then back to 0.05 again. And that makes sense that the change rate is fairly consistent. But again, this is in grams, and um, this is in grams. So we want to convert it to moles. So to do that is we just want to do the mole of CO2 lost. And well, we know how to go from grams to moles. This is going to equal this cell divided by 44.01 and hit enter. Obviously that's going to be 0, but we're going to drag this down. And now we have the moles of CO2 lost. Now, we're really not interested in that because we're trying to compare it to molarity. So we're going to use the mole ratio for the mole of HCl. And this is how many moles of HCl is basically being or disappearing, um, disappearing in the beaker, mole of HCl disappearing. And so it is related to the moles of CO2 appearing or being released as a gas, and it's related by the mole ratio. So this cell should equal uh, the mole times the mole ratio, which is 2 to 1. So I'm going to do a times 2 and hit enter. And obviously 2 times 0 is 0, but I'm going to drag that formula all the way down. And it's just doubling the moles of CO2 because of the 2 to 1 ratio. Now, the next one is we want to figure out how many moles of the HCl is basically being used up in the beaker. And we started with 0.360. And we got that 0.360 moles because it is 12 molar and I use 30 mils. So if you take 12 times 0.03 liters to get the number of moles, then we're good to go there. And so the remaining numbers will be this amount. So this is going to equal this amount, and we want to subtract this amount and hit enter. So this is how much it's being reduced each time. So I'm going to go and pull that down. And that is, let me see if that's working. 3, 5, 6, 7, 3, 5, 4, 2, 1, 8. Yeah, so it's going down and down and down and down and down. So we're good to go there. And then we want to basically switch this to molarity. So this is um, moles of HCl used in beaker, and then we want to convert that to the molarity of HCl in beaker. So this is the concentration. And basically to do that, this is going to equal the number of moles, right? That's the number of moles. And then I'm dividing it by 0.03 liters. And that's going to be my molarity. And lo and behold, I did start with 12 molar. And again, I want to pull this all the way down. We want to pull this all the way down. So now we have the molarity. So our next column is going to be the natural log of the HCl concentration. So this is going to equal Ln. And so we're going to do the natural log, open parentheses, do the cell, don't forget to close parentheses and hit enter. And then we want to drag that formula all the way down. So that's our natural log. And the next one we're going to do is 1 divided by HCl, close bracket. So this is going to equal 1 divided by, not this guy here, the concentration, and hit enter. And that we will then follow that guy all the way down, and we're looking like this. So to make your graphs, let's copy, control copy, and we're just going to put one down here. Let's do this versus this, control copy. Now when you paste this, when you go paste, I want you to go to paste, and you just want to paste the values, right? You're just pasting the values, not the formulas. Let's not send it all over God's creation. Let's just paste the values. You're going to highlight those, go to insert, and go to recommended charts. And molarity of HCl in beaker versus time. That looks awesome. I'm going to say okay. That's going to be my molarity versus time. And of course, we can, what can we do? We can right click on here. We can add a trend line. And then we can display an R squared, and we're good to go with that one. So let's do another one. Let's copy time, control copy. Let me put it over here, control V. And now I'm going to do the natural log, control copy. Now over here, I'm going to go control V, but again, I just want to paste the values. I just want to paste the numbers, make sure they're matching. That we don't have any kind of loop logic in the spreadsheet. Highlight, go to insert, let it recommend the chart. That looks good to me. That's a scatter chart. Again, let's right click on that line, say let's add a trend line. Let's display an R squared. We're at 99.7, 99.8. So then I have one more I need to do. I'm going to highlight the time, control copy. Let me put it down here, control V, and then I'm going to do the 1 over HCl and control copy again. Down here, when I go control V, I want to just paste the values, and then I'm going to go to insert and let it recommend my chart. This guy looks great. So this is my 1 over HCl. Obviously, you can add axis and everything. Right click that number area. That's what I was missing today. You want to add a trend line and display the R squared. This is 0.995. We got 0.997, 0.998. So from this information, and that's even with my little wonky donkeys out here, you're looking for kind of the straightest, most linear relationship. And now you're like, okay, so what's it going to be? What is it a first order in respect to this, second order, or third order in respect to the hydrochloric acid? And what you can do is you can literally just go, okay, what happens when the concentration is halved? right? What's happening to the rate? Well, the rate is the difference in time. So you can do your, final minus initial. So your difference in time divided by your difference in concentration. You can get a rate and see, is your rate uh, um, halving when the concentration halves? Is your rate doubling when the concentration doubles? So that will help you. And I super duper hope that this helped you guys in um, how to do this data.